focusing on the SQL SELECT statement. In this lecture, predominantly we are going to focus on where clauses, how to select from multiple tables, as well as how to leverage joins. Let's start with the select statement. As we've seen in different lectures so far, the key for us when we're using SQL is to really look at what we are trying to do, where the information is getting pulled from, and the conditions of which the statement needs to meet, as well as the order of the results. So if we're looking at a select overview, we're really going to be looking at what specifically we want to select from the tables that we've identified. Once we have determined whether or not we want to select distinct or select all from one or more tables, we will focus on the different conditions as well as how we want to either order or group by in terms of having the right conditions to provide the right results. So as I look at those different components, the most common that we're going to see is select from where. I've highlighted this in yellow just to show overall what you're going to see predominantly throughout the review of select from where. If we're going to use as an example from tables, let's start with some student IDs, some course IDs, and some grade IDs. As you'll see, the student ID is marked off with a 4-digit ID code with the last name and first name, the course with a 3-digit ID code, as well as then a score for the mark or the grade. As we use that, if I were going to do a select statement to show all, I'm going to end up with duplicate entries based off of this data, as you can see, provided before. So I've got John Smith, Mary Jones, Jane Brown, Mark Jones, and John Brown. And as you see, I've got two different Joneses, Mary and Mark, and two different Browns. So if I'm going through and selecting all, I'm going to see Smith, Jones, Brown, Jones, and Brown if I'm looking at just their last names. However, if I want to see distinct last names, I'm going to be able to insert the distinct after the select command, and it's going to show that there's only 3 distinct last names, Smith, Jones, as Brown. So if I'm going with all, I will get all, and that is the default. If I go with distinct, I'll get the distinct numbers. Again, using this example, if we go through and we are using the where clause, usually you don't want all the rows of your data. We're going to use the where clause to essentially restrict what we're looking for and provide some conditions around the component. So if we look at this from a high level perspective, we want it to be where a grade is higher, where one grade is higher than other, if there's a passing grade, if my first name equals John, if my last name equals MacArthur, if I'm looking at my first name is John and my last name is Smith, if I want everyone with higher or lower than a C average. This slide just shows a couple of those examples as well. If I'm going to show anything where my mark is lower than 40 or greater than 70. And we can accomplish this with some very straightforward SQL. So if I'm looking to select all from the grade where mark is greater or equal to 60, I'm going to pull off the different grades from those classes with both the student ID and the course code. Now then, if I want to show distinct components, I'm going to be able to get it both from just an ID perspective with the distinct ID. So that way we can see that these distinct IDs all had marks greater than or equal to 60. So if we were going to look at this from a where example, given the table that has my grades from an ID code perspective, a code, and a mark, if I were to write a SQL query to list the ID numbers and marks of students who have passed or scored 40 or higher, one way I could do that is by selecting both the ID and the mark from the grade and do a dual condition where the code equals IAI and the mark is greater than or equal to 40. Because this scenario, we only want the ID and the mark. We don't want the code. An additional view from this perspective is looking at the conditional clause in terms of where the code equals IAI, because that's really what we're interested in. We want to make sure that we're siloing the information in such a way that we're getting all of the main components and getting the results back as cleanly as possible. Now, as you're going through this, we're going to be looking at some of the different syntax in the course, where I'm not going to get very particular with you on grading in terms of proper use of colons, ampersands, etc. But if you look at this, when you're doing a separation from a condition, if you want a specific value, you're going to want to use single quotes. So from here, we're looking at code equals IAI. So it's using single quotes around the string to specifically call it out. And if you look at it then from a mark perspective, the condition is showing how we are doing the mark at greater than or equal to 40. Once we've gone through that, you'll see that we can look at doing both a select from single tables as well as from multiple tables. So if I'm going to do a select from multiple tables, oftentimes you really need to know what you're going to do and how you're going to piece it together. So if I'm going to want to select, let's say, a price of the average, a price of the hamburger, as well as the salary of an employee from a local McDonald's. You need to make sure that you have columns with the same names. Or if I want to show the number of beers sold at Gators on Friday by Jan, you're going to have different pieces of information, and you'll be able to get around this by making sure that you resolve reference columns with the table name and the column name. For example, if I want to select the first, last, and mark from student and grade, where student ID equals the grade ID and where the mark is greater than 40, it allows me to essentially pull those two tables together in a query and get the results across all the different information. This allows you to really leverage the relations and highlights all of the entries from the grade table that meet the select statement. And it ensures that they're matched with the first entry from the student table and with the second, and so on. So if I'm looking at the select from student grade where student ID equals grade ID, the yellow highlighted shows that, and then move from there. Now, one of the keys when selecting from multiple tables is to always make sure you use the where clause to find the common values. So this example is showing a select all from student grade and course where the student ID equals the grade ID and the course code and the grade code are identical. This allows you to pare down the information in such a way that you can select it from multiple tables, tie the information together, and be able to properly form the results together into a simplified view. As we look at the joins, joins are a key topic when we're looking at how to best combine tables. So the four that we're going to talk about and that you'll see later on in exam are the concept of a cross join, an inner join, a natural join, and an outer join. When we get into outer joins, they're really linked more with nulls. I'd like to wait to go over that and come back to that at a later date. When I talk about a cross join, it's going to basically return all of the rows from both tables. If I'm looking at a natural join, I'm going to be returning pairs of rows with common values for identically named columns and without duplicating columns. And if I'm doing an inner join, I'll be returning pairs of rows satisfying a specific condition. Here's a good example of a cross join. I've got student ID and name and enrollment ID and course code. And I'm doing a select all from the student cross join. I'm getting all the information relevant to the ID and relevant to the course code and name. If I'm looking at a natural join, I have the same data that's a part of this with the student ID and the name, as well as the enrollment ID and the code. If I'm going to do a select from all with the student enrollment from natural join, I'm going to be seeing both the ID, the name, and the code in a combined results view. As I look at a cross and a natural join, if I'm doing a select all from a cross join, it's really doing a select all from table A and table B. It literally allows you to essentially simplify the SQL statement. So this example shows if I'm doing a select all from a natural join, it's really the same as this longer SQL statement where I'm looking to ensure that I'm matching each of the individual columns. It saves you a lot of code review. When I'm looking at an inner join, I'm specifically looking at conditions where the pair of rows satisfy individual components. So if I'm selecting all from an inner join on a condition, it's allowing me to choose rows where the columns are equal. For example, if I'm looking at the student and enrollment tables, student ID, enrollment ID, name, and code, if I'm using this from the inner join perspective, it's going to pull together all that information into one larger table. Again, if I'm looking at it from an inner join perspective, this is a good example of select all from buyer, inner join with property, where the price is less than or equal to budget. This is allowing me to go through and map the specific items together from a problem-solving perspective. So from a parallel perspective, a select all from an inner join B, A join inner join B is the same as really saying select all from A and B. Again, it's really just about simplifying the code. So if we're looking at this from a high-level perspective, joins so far are not needed in what we're trying to do. They're going to have the same effect from multiple tables and really get into some deeper areas within the code. But I wanted to make sure that you're seeing this as we get a little deeper into the semester. So should we use joins or not? Some say yes because they lead to more concise queries, and natural joins are very common. And no, because support for joins varies among SQL dialects like PL SQL. So as we're looking at doing the group project in Access and stepping through some of the exercises, we can probably go with a limited amount of joins, but when we come back to doing SQL Server later in the semester, we'll want to make sure that we understand joins properly. Now, in the next virtual lecture, we'll be talking about writing queries, and I want to make sure that I leave you with some of these thoughts. With the SQL components from a select from where perspective, when we're writing queries, there are often many ways to write it. What you need to do is keep it simple. I've been saying that all semester. Don't try to be clever. Keep it basic, keep it straightforward, as it'll allow you to be the most efficient. If you're dealing with different database management systems like SQL Server and Oracle, some of them are going to have query optimizers, but really the more simple you keep the query, the easier it's going to be to optimize. And we'll look at some ways to improve efficiency later. And this is the end of the virtual lecture on the select statement.